Let's get some more practice with dealing with fractions. Example 3 wants us to multiply the two fractions and reduce our final answer. So we have 5 over 22 times 2 over 15. And if we follow the rules of multiplying fractions where we multiply the numerator and multiply the denominators together, we'd get 5 times 2 over 15 times 22. Now notice that in previous examples, I would have actually multiplied those numbers together, but for right now, I'm leaving them not multiplied. And I'll show you why that is, because ultimately, if we were to multiply this, we would get 10 divided by, let's see, what is 22 times 15? So we have 10, 2, so 330. Now, 10 divided by 330 or 10 over 330 is not a simplified or reduced fraction. Now notice both of these numbers are divisible by 10. And so if I divided them both by 10, then my final answer should be 1 over 33, and that will be in the reduced form. Another way of getting there is I could rewrite this fraction here as 5 times 2 over, I'm going to separate 15 into 5 times 3, and I'm going to separate 22 into 2 times 11. Now notice the 5 in the numerator and the 5 in the denominator, 5 divided by 5 is 1, so those will essentially cancel out. And this 2 and this 2 will essentially cancel out and be left with 1. So we have 1 times 1 over 3 times 11, which if you simplify that would give us 1 over 33, which is again the answer that we ended up with doing it the other way. So I just wanted to provide you with two different ways that you could go about simplifying that problem. Either way you do it, I'm okay with, as long as you get the correct final answer and you're not getting there by coincidence and you're actually doing correct math. As long as you're doing correct math and you just get there a different way, that's fine. Example 4 wants us to divide the two fractions and reduce our final answer. So we have 3/8 divided by 2/5. Hopefully you recall that when we're dividing fractions, we can make it into a multiplication statement by taking the reciprocal. So 3/8 divided by 2/5 is equivalent to 3/8 times 5 over 2. And if we go ahead and multiply the numerators together, we have 3 times 5 over 8 times 2, and that is 15 over 16, and that is as reduced as we can get it. Now you might be asking yourself, how do we know that we can't reduce it any further? If we were to break down these numbers, both the numerator and the denominator, into its factors, so 15 can be broken into 3 times 5, and 16, there's several ways we could write it. We could write it as like 4 times 4. However, both of those can be broken down. So we could rewrite it as 3 times 5 over 2 times 2 times 2 times 2, since each of these are 2 times 2. So notice that the numerator and the denominator doesn't have any of these what we call prime factors in common. So since we've broken it down like this is the way that we can tell that 15 over 16 is as reduced as possible. Example 5 wants us to add the two fractions together and reduce our final answer. So we have -3/2 plus 2/5. We need to find a common denominator whenever we are adding or subtracting. So I'm going to multiply the left-hand side by 5 over 5, and then the right fraction, I'm going to multiply it by 2 over 2. And if we do that, we get -15 over 10 plus 4 over 10. And our final answer will have a denominator of 10 And then our numerator would be negative 15 plus 4, which is negative 11 over 10. And that is our final answer, and it is reduced because 11 is a prime number and 10 only factorizes is into 5 times 2, so we can't reduce that any further, and negative 11 over 10 will be our final answer. Example 6 says subtract the two fractions and reduce our final answer. So we have 7/8 minus 2/3. And again, I want to find a common denominator, so I'm going to multiply this by 3 over 3, and I'll multiply the second fraction by 8 over 8. And if we do that, we get 21 over 24 minus 16 over 24. And our final answer will have a denominator of 24, and then the numerator will be 21 minus 16, which if we subtract 21 minus 16, that should give us 5 over 24. And that is as simplified as we can get it. So that is our final answer there.